Go back and look. I have 4 hydrogens, 3 oxygens, 1 nitrogen, 1 nitrogen. Okay. Okay. Now I multiply by 2 to get rid of the E's, or the electrons. That was not bad. I'm sorry about that. So now I end up with 3 coppers going to 3 copper ions and 6 electrons, 8 hydrogen ions plus 6 electrons plus 2 nitrates going to 2 nitrogen monoxide plus 4 waters. Make sure I've done everything. Okay. Now my 6 electrons are on opposite sides. They're equal to each other. They can be canceled. Is there anything else that can be canceled side to side?
The water and the hydrogen.
Why would they be allowed to be canceled?
Because it serves a purpose.
Are they the same?
No.
No, then they can't be canceled.
Oh.
You can't cancel apples and oranges.
Oh.
They have to all be apples.
Well, then the copper?
Huh? Is this the same? This is copper metal, and that's copper ion. So the answer is? No. Can't cancel anything else out. So now we simplify. We add up the equation. Whatever is left, it becomes my net ionic. So read and bring down. 3 copper plus 8 hydrogen ions plus 2 NO3. I'm sorry, I should have a chart on that one. Yields 3 copper, 2 plus 2 nitrogen monoxide plus 4 waters. Yeah, just had a negative sign attached to it. I did not do that. This is what you would want to write as your answer. And let's go through it and make sure, let's see if all the parts of it are there. There's our copper metal. There's our nitrate ion. We can't cancel it out because it's converted to nitrogen monoxide over here. There's also nitrate ions in solution, but not all of them are being used with the copper 2. Some of them have been converted via oxidation changes to nitrogen monoxide. It's acidified, so we have hydrogen ions. Whenever we have hydrogen ions in solution, we're going to have water as a product. That's a guarantee. If this said it was in a basic solution, if we went through all of this and it's in a basic solution, we would add an even number of hydroxides to either side. Okay, we may look at one of those in a little bit. Okay, now let's look and see if everything is balanced. We have 3 copper, 3 copper, 8 hydrogens, 8 hydrogens, 2 nitrogens, 2 nitrogens, 6 oxygens, 2 plus 4, 6 oxygen. Charge. I have 8 plus, 2 minus, which is a 6 plus charge, and I have a 3 times a 2 plus to a 6 plus charge. So the charge has to balance side to side, as well as the atoms balance from side to side. Now that's a lot of work to go through for 4 points. 1 point for these, 2 points for these, 1 point for the balance. So if you see a problem like this, attempt it. If you're not so comfortable with it, at least give it a shot. At least provide a reasonable answer and balance it. You'll at least get 1 point for the balancing. Or write the reactants. You know, let's say you see this and you freak out. Write this at least. then since since I told you that every time you have hydrogen ions over here, you're going to have water as a product, write that. If you do that, okay, this is hydrogen ions, you have water as a product. This dilute, you get this as a product. If this had said concentrated, you would have NO2. If you write that and don't go any further with the problem, that's 3 points. 1 point for the reactant and 2 points for the product. Okay? It's not 5 points, but it's 3. And so this is a lot of work to go through. And every once in a while they'll ask you a question like this. Let's answer the question and then we'll take our break. Explain the change in oxidation state of chlorine. Oh, wrong one. Where am I? Wrong page. What happens to the pH of this solution as the reaction proceeds?
The number goes up?
The number goes up. Why?
Because
there's less free hydrogen ions floating?
Very good. There's less free hydrogen ions that are going to be available. So notice hydrogen ions as a reactant, water as a product, so hydrogen ions are being consumed. Yes?
So for the non-reactive elements of this, there's still hydrogen ions floating around and there's still nitric ions floating around, but since they're not reacting, we don't worry about them?
Well, we see hydrogen ions as part of our reactant. There still may be others that are being consumed. But yeah, the nitrate is here because nitrate goes 2 ways. Nitrate goes to copper nitrate, which is soluble, but nitrate also goes to nitrogen monoxide.
Okay.
So we don't show nitrate over here with the copper because it's a soluble salt.
Okay.
But we have, sorry,
So in the bottom, even though normally there would only be 2 hydrogen ions for every ion of nitrate and extra nitrate are made up because they're combined with the copper?
Right.
Okay. And because it's a +2, it would have to be 6 of those, so it's perfectly balanced.
Right.
Okay.
Yes. Okay. If you do lots of these, you can go straight from the words to this. But you have to know, you have to be very comfortable with redox problems in order to do that. And quite honestly, most college students are not that comfortable. Okay, so if you see a problem like this, remember those simple tricks. If you can remember the simple tricks, you can at least get 3 points out of it. And maybe 4 if you answer the question at the question part. And then all you would lose out on is the points of balancing. Okay? So try to go back and look at some of the information that's on those pages that I gave you, and it will help fill in some of these little tricks that are there. Okay? So maximize your points.